So this video tonight is going to focus on our last learning target for our forces in action unit, which is analyzing the forces involved on a swimmer using Archimedes' principle. The first thing I need you to do is to get out your unit organizer, and in slot 15 we're going to write Archimedes and buoyancy notes, and it is worth no score. On this note sheet, we're going to make sure we write a 15 in the upper right hand corner. And the first question we're going to ask ourselves this evening is, what is buoyancy? And buoyancy is the force of a liquid that pushes on an object. Buoyancy acts upwards and opposes gravity and determines whether an object sinks or floats. Now, Archimedes' principle deals with buoyancy, and Archimedes, who was a scientist in Greece a very, very long time ago, said that the buoyant force on an object is going to be equal to the weight of the liquid displaced. So for example, in the picture we have down here, we currently have a 7-pound object that's not submerged in water and no water in the bowl next to it. So total here we have 7 pounds. Well, we all know if we get into the bathtub or a swimming pool, we feel a lot lighter, and that's because of the buoyant force. So what happens is when we submerge this weight in water, it magically becomes 4 pounds. Well, where do the other 3 go? Well, there are 3 pounds of force pushing upwards, and this weight displaced or pushed aside 3 pounds of water down here. So we have 4 pounds for the weight plus 3 pounds for the water. So then total, we still have 7 pounds. So the buoyant force, which is 3 pounds, is going to be equal to the weight of the water displaced. And the water displaced plus the weight of the object is going to equal to what it is normally. So this is kind of like conservation of mass. None of it's going to go away. It's just released in different forms. Now, we talked a little bit about fluid displacement a couple seconds ago. And fluid displacement is when an object is placed in liquid, it pushes fluid out of the way in order to take its place. So we use the fluid displaced we make that equal to our buoyant force. So what happens, what do the forces look like if an object floats or sinks? Well, first of all, we need to fix a typo. This is not F of G. This is going to be FB. Same thing down here. My deepest apologies. So if an object floats, the weight of the fluid, which is our buoyant force, that's going to be displaced, is going to be greater or equal to the mass of the object that we put in the fluid, the mass of the object. We also can use weight of the object here, so we can use Fg for this one. Well, what does that look like? So say we place an object in water, and then if it's floating, that means that the gravity or the weight of the object is going to be less than the buoyant force. So our buoyant force, or the weight of the fluid displaced, is greater than the mass or weight of the object. And the same thing happens if it's equal. So we can put or, we have our weight again, and if we have it floating on top of the water, we have our mass of our object, or our weight of the object, equal to our buoyant force. So again, the weight of the fluid displaced, or our buoyant force, is equal to the weight or mass of the object. If the object sinks, that means the weight of the fluid that's displaced, so our buoyant force, is going to be less than the mass of the object. So again, this is our weight of the object. So we have weight of the fluid displaced versus weight of the object again. So what this looks like is if we have our object and we put it in water and it sinks, that means that the weight of the object is going to be greater than the buoyant force, or the weight of the fluid displaced. So our weight of the object, or mass of the object, is going to be greater than our buoyant force, or the weight of the fluid displaced. Turn the page over. We have two scenarios, and I think this will help clear up a lot of confusion that I'm sure a lot of you are feeling right now. So if the mass of an object we put in water is 8 grams, and we measure the mass the water is placed as 10 grams, which way is it sinking or floating, and how can we tell? Well, the first thing we should do is draw a picture. So we're going to draw our object, and we're going to write down that the mass of the object, which is our F of G, it goes down, so it's 8 grams, and our mass of the water displaced, which is our buoyant force, is FB, and that's what's going up, so that's 10 grams. Well, because the mass of the water displaced, or our buoyant force, is bigger than our mass of the object, or our weight, that means the object's going to float. So the mass of fluid displaced which is our buoyant force, is greater than the mass of the object. So again, if the mass of our object is less than the mass of the water displaced, it's going to be floating. And then we can move on to the next one. In scenario 2, the mass of our object is 20 grams. So when we look at the mass of the object, it's F of G, so the weight of the object, and the mass of the water displaced, which is acting as our buoyant force. So if we have our object and the force pulling downwards is F of G, and it's equal to 20 grams, is going downwards, and then going upwards we have 17 grams, which is going to be representative of our buoyant force. Are we expecting the object to sink or float? Well, we're expecting the object to sink. And how can we tell? The mass of the fluid displaced which is representing our buoyant force, is less than the mass of the object. So the next time we see you in class, we're going to be doing a lab on Archimedes' principle, and we're going to be filling up a film canister or a boat with sand and measuring the amount of water that is displaced versus the mass of the boat. And I'm hoping that the lab will make a lot of these ideas more concrete.